You should have a lot of basic information by now that will get you ready to take measurements. However, you should be able to present the data in a table and a graph. That is what we will do for the last three lectures in topic 1.2, and I believe you will find them both interesting and useful. We will use one of the most common examples of motion, a motion of falling object under the influence of the Earth's gravitational force. In addition, we will consider what we call a free fall motion, in which air resistance is ignored. The fall distance is much smaller than the radius of the Earth, and we ignore the effects of the Earth's rotation. With this condition, an object will fall with a constant acceleration, which we call gravitational acceleration g. The distance traveled by an object falling from rest was predicted by Galileo to be related to time by the following relation: d equals 1/2 gt squared. In this experiment, we drop an object from 5 different heights, and we time how long it takes to fall. And this is what we got. The first column here is called the independent variable. This is what we constantly change during the experiment. We vary the height from which the object is dropped, and we record the time. So the time here is the dependent variable. This is what we measure. And to make the results more reliable, we repeat the experiment. In this example, we take 4 measurements for each height value. At the very top of the first row, we write the quantity slash the unit. This tells us that the height is measured in meters, and the time is measured in seconds. And since the unit has been specified in the first row, the data or the numbers in the subsequent rows are simply written without the unit. And these are the measurement uncertainties. These numbers are most likely from the measuring device that we use to measure the quantities.